What's going on, everyone? Welcome back to the channel, and in this video we're going to talk about Friday's enhanced risk. As you can see on the screen here, this risk covers much parts of the Midwest, Mid-South, and also Dixie Alley with an enhanced risk of level 3 out of 5. As we go to our probabilistic, we can see that the hatched area, which is a 10% or greater probability of significant severe weather within 25 miles of a point, encompasses over 21 million people, with cities such as Memphis, Tennessee, Nashville, Tennessee, St. Louis, Missouri, Birmingham, Alabama, and Jackson, Mississippi. With this information, let's go ahead and get into the models. We're going to go ahead and start with the 500 millibar chart. On this chart, we're looking for our troughs. They're going to be areas that are going to create low pressure, enhance vertical motion, and also storm development. As you can see, at 7 a.m. on Friday, there's going to be a trough located over the southwest Great Plains with a pretty neutral tilt. Over time, with the advection of relative vorticity dominating the Rossby wave, this is going to continue to transverse to the more of the northeast section. With that information, let's go ahead and put this into a loop and see how this develops. So as you can see over time, a couple different things. The axis of that trough is definitely becoming more negatively tilted, and by you see at 7 p.m. Central Daylight Time, we definitely see that it does have a little bit more of a neutral tilt, which is going to enhance storm development and severe weather. And also, in addition, we have this nice jet streak right there that's coming through parts of Arkansas and also into Missouri. Then if we go ahead and continue on a couple more, we can see that as that trough moves up to the upper Midwest, we can see this next trough that is developing back across the southwest of the Great Plains. That is going to be the precursor for Saturday's event. Now let's go ahead and take a look at the vorticity of that 500 millibar chart. So the vorticity is going to be the spin in the atmosphere, which is going to be a big crucial factor for storm development. Once again, over the southwest Great Plains, you can see that we have our trough, and inside that trough we have a lot of the vorticity. And as we go ahead and put this into a loop and see how this affects over time, we can see that as that trough tilts more negative, it's going to be affecting into much parts of the Midwest. And by 0Z, we definitely have a lot of vorticity and spin, which as we continue on, I believe that southeast Missouri might be a crucial point to look out for, especially inside this enhanced risk. As we go ahead and continue moving on from there, we can see that there is a lot of vorticity that's going to develop too, that's going to keep transversing, which will probably put this into a QLCS as time goes beyond. But definitely in that southeast Missouri region, looks like there could be some supercells before they possibly get nudged into the line. Now let's go ahead and look at our 250 millibars, or our upper level jet. Here we're looking for areas of divergence, or also known as the defluence of winds that creates the divergence that's going to increase vertical motion and also jet streaks. So starting off here at 7 a.m., you can see that the main jet streak is located over here in parts of Texas. Now that's going to follow this Rossby wave too, and it's going to vect off into the northeast. So let's go ahead and put this into a loop and see how this develops. So we can see over time that the more of the upper level jet is kind of increasing, but also too there is more of the defluence of winds. For instance, if you could see here more in northeast Missouri, you have winds going in more of a northeasterly direction, and even parts in here in the Arkansas, it's going into more of an eastern direction. So this whole giant area right there looks to be a good region for storm development and a lot of severe chances, especially at 7 p.m. Central Daylight Time. So let's go ahead and continue to put this into a loop and see how it transverses over time. And as we can see, and we get into the later hours too, it looks like a lot of the defluence is going away to looks like this will be absorbed into a QLCS line throughout the remainder of that night. Next, let's go ahead and take a look at our 700 millibar chart, or our mid-level winds. On this chart, the main thing we are looking for is going to be short waves. So as we can see at the current time here at 7 a.m., there's definitely a short wave throughout here, which you can tell with the dipping of those isobars. And those always are going to be dominated by the advection of relative vorticity, or simply meaning they're going to continue to follow the flow off into a easterly direction. So with that being said, let's go ahead and put this into a loop and see how this develops. So as we could see, there's definitely that 700 millibar jet is also increasing too. And if we keep on going up until about that 0Z, we can see a couple different things. First of all, we definitely have a couple different short waves in here. We have one through there, and we also have one kind of like back throughout there. And also being underneath as far as that jet also gives us another convergence of evidence as we go through these different models to determine why I believe that southeast Missouri looks to be a focal point given the current run of this model. With this information, let's go ahead and continue on. And we can see over time that that lower level jet is going to definitely weaken, and the short waves are not nearly as pronounced, but it does have a strong pressure gradient, so the winds could be strong, but it definitely favors more of a QLCS event, and it should be, the storms will not be strengthening at this time. Next, let's go ahead and stay at the 700 millibore chart, but take a look at the vertical velocity, which is going to help with areas of uplift for storm development. So as you can see here at 7 a.m. on Friday, there is a solid region that's kind of throughout there in the kind of parts of the central southern plains and also parts of the Midwest. So let's go ahead and put this into a loop and see how this vertical velocity develops over time. So we continue on, we can see that as far as that trough that's being vected off to the northeast direction, and by we get at 7 p.m., we definitely see this area right there looks to be a good focal point, especially right there. It definitely shows that that's probably going to be a line right up until there. We're going to have some more discrete supercells ahead of that line, and as that line more develops and transverses off to the easterly direction, it will get absorbed by that line, but even with a nudger effect that could give higher chances for tornado genesis as well. So with that information, let's go ahead and continue on, see how this vertical velocity develops. And we can see that there definitely looks to be that squall line or QLCS that is going to continue on going through parts of Illinois up until about 1 a.m. It looks like the vertical velocity is diminishing and those storms are going to start to weaken. Now let's go ahead and use the NAM-NEST, also known as the NAM 3 kilometer, to do a comparison of this vertical velocity. And this will also give us a little bit greater detail of that vertical velocity. So as 7 a.m. goes on, and we continue on throughout the run, we can see that there's definitely a lot of different areas of upward vertical velocity, especially in parts of even Nebraska. That's going to be more closer towards that trough too. That's going to help with the vorticity and the spin. And as we transverse through time, you can see that line is developing throughout much parts of Iowa and into Missouri. And then if you look down there, about like southeast Missouri, there looks to be, according to them, some more discrete areas of vertical velocity. Is why another factor of why I believe in kind of that region that there's going to be some supercell development and also to the greatest risk for tornadoes. Now let's go ahead and go to the 850 millibar chart, also known as our lower level jet. So here we're going to be looking for pretty much our lower level jet, also the difference in the direction of the jet too. So as you can see, starting off in 7 a.m., we have that jet max, which is through much parts of the southern plains. So let's go ahead and put this into a loop and see how this develops throughout time. So as we go out through time, you can see a lot more of that jet is being infected in parts of Missouri and also into Arkansas. And by when we get to about 0Z, we see a new jet max that is across the border of Illinois and in Missouri, and even to that southeast part of Missouri. With that being said, that definitely shows that there is a lot of area for higher chances for uplift and also to possibly tornadic development, depending on the different winds, especially with these winds that are coming out of more of the southerly direction. This is also going to be a moisture transport. So as you can see with these winds coming here and going up, that's going to be a whole moisture transport that's going to help evac that Gulf moisture up northward into that area right along that jet streak, and is why 7 p.m. is looking like it might be a very good time to take shelter in those parts of the country. So with that information, let's go ahead and continue on. You can see that that jet streak definitely develops more, and by we get to about 10 p.m. in parts of Illinois, but I just think that other features there might be a little bit higher, but I believe in Illinois that could be showing a good risk for damaging winds or even intense straight line winds that could show as far as similar to like tornadic damage, and is definitely not something to be take lightly. I just believe that the tornado risk is going to start to diminish over time. Now let's go ahead and take a look at the dew point temp at this same 850 millibar level. So here we are, 7 a.m. As we can see, there's not a lot of moisture except in the upper Midwest and Northern Plains region. So as we go throughout time, we can definitely see that moisture advecting from the Gulf, kind of like I was talking about, how it's going to follow those winds and be into much parts of the Mid-South and the Midwest. And then by the time we get to about 0Z, you can definitely see as far as there's a lot to work with. Looks like there's some kind of a low, an occluded front, and then you're going to have this cold front that's going to be our main forcing mechanism with plenty of moisture ahead of that line to work with. So with that information, let's go ahead and keep on going throughout a little bit of time. And you can see even that 03Z, if that strong lower level jet, there is a good area of moisture too. So right around 10 p.m. And then we continue on, and it looks like to be a good parts of moisture, but other atmospheric dynamics are going to be falling off. So definitely as far as some good chances for as far as like some other types of severe weather, but I just think less of a tornado risk as the storm goes from Illinois into parts of Indiana and eastward. All right, so let's go ahead and go to the surface. So as you can see, starting off at 7 a.m., we have our low pressure system that's over western Nebraska. And then as we're going to go ahead and put this into a loop over time, we'll see how our low pressure system and our fronts are going to develop. You can see a lot of areas as far as that low pressure is tightening. And let's do this for kind of like a model consensus. So 7 p.m., we can see we have that low pressure throughout here. We're going to have an occlusion front that's going to be right about there with that cold front that's going to be through those pressure tongues, the wind shifts, and a little bit of the temperature gradient too. And if we go to our dew point temp, it matches up pretty well. So that gives us another summation that our front placement looks in a good spot. And also even with the wet bulb temp too, as you can see on the back side of the front, you have more 40 degrees temperatures. On the front side, it's going to be more 50s into 60s. And especially here with that occlusion front too. So it definitely looks to be, that's going to be our level of our front right around that area. So let's go ahead and put this into a more of a loop and keep on going. So there we go. So 03Z, about like maybe when the intensity will, after this time, start to diminish a little bit. So we're going to have our low pressure system there. It's like an occlusion front still there. And then oh, that's the total opposite way I want to go. And then of course down through Illinois, and all the way down through there with our cold front that's going to be help driving that squall line that's going to be moving off to the east-northeast direction. Now let's take a final look at the dew point temp and our lifted index at the surface. So here we are at 7 a.m. Central Daylight Time. So the main things we want to look for is going to be areas to where you have your blues of 60 degrees Fahrenheit or greater, and also -4 or higher for our lifted index. That's going to indicate high instability and chances for severe weather given other parameters and fronts and lifting mechanisms, jet streaks, you name it. So as we go ahead, go through a loop, put this out throughout time, we can see that there's going to be some more moisture that's going to be evected throughout Arkansas and even into parts of Missouri. So right there on that southeast side, we can see that it's 62 degrees Fahrenheit. So we definitely have, as far as our ample moisture, with the lifted index even being at -6, -5 at parts. So that's also gives us another congruence of why I really believe this area is going to be an area to look out for around 7 p.m. Central Daylight Time, given the current run. So go ahead and continue on. We can see that moisture is being evected a little bit more often to parts of Illinois. Let's go ahead and take a quick look here. And yeah, as you can see, the instability in there is definitely dropping off. So it looks like less chances, but the instability in more parts of the border Missouri and Illinois and southern Illinois looks to be like that could be possibly staying a little bit stronger, but also as time dwindles, that will dwindle off throughout the rest of the night. Now let's go ahead and take a look at our mixed layer cape / our mixed layer SIN or convective inhibition. Here we are, 7 a.m. on Friday. Go ahead and continue in time. You can see there's areas developing, that especially there in parts of Iowa and in Nebraska too. So as that risk shows, it definitely more parts of eastern Iowa looks to be at risk. But even as we get to a 0Z or 7 p.m., this also just really shows that extra, and it's kind of hard to see with those pinks, but an extra area, kind of like I was talking about too, that definitely shows as far as adequate amount of our cape, which is pretty much like thunderstorm fuel, right? You can have the other elements, but if you don't have the fuel to go with it, you have nothing, and vice versa. So it looks like to be in that special area about 1,500 joules per kilogram, which is definitely going to be enough of the cape to work out with. And then let's go ahead and put this into loop. See how it keeps on developing. And as you can see, yeah, 03Z, that matches up good too with our other parameters around that kind of like more southern Illinois region. It looks like that will keep the instability and the chances for severe weather going on. More in this northerly direction, less of the Cape, but that could be displaying possible higher chances for microbursts and damaging winds too. So definitely something to be on the outlook for. I'm just talking to more of like a tornadic probability. Looks to be more in that southerly direction, in my opinion, looks to be more favorable at that time. Now let's go ahead and take a look at our most unstable Cape and our shear. So here we're looking for our shear vectors to be having that flag or about 50 knots. So here we are, 7 a.m. As we go ahead and continue on time, you can see that's being affected into more northern Missouri and goes into parts of Iowa. And then around that 0Z time too, you can see a couple different areas, right? So you got more kind of like a northerly direction and then also the southerly direction too. Now let's go ahead and compare those two. So let's go back to our surface front, draw on the fronts, and then I can kind of show you the angle of the direction. So let's see. So we have that surface front with the occlusion and then more of that cold front that's going to drape long lines of here. So let's go ahead and go back to that convective parameter. That line drew really badly. Geez, that was crazy. But anyways, you can see that's throughout the line here too. And even more in the southeast Missouri region too, you can see that it's a little bit more of a kind of like a northeast direction. But the main thing is if you have these shear vectors, right, you have your line along here. If you have your winds kind of like along here, more northern Missouri and parts of Iowa, if it's more of a parallel to the boundary, it's going to be a higher indicator for a QLCS or a squall line. Compared to it's got a little bit more of an orthogonal or perpendicular, that's going to increase the chances for supercellular development. Now let's go ahead and continue on a little bit. And we can see that, like we were talking about at 10 p.m., those parts as far as southeast Missouri and to more southern Illinois and even parts in Kentucky, Arkansas, and Tennessee, especially with the most unstable Cape, it's going to also indicate a good chance for more of a nocturnal threat. This looks to be plenty of sufficient as far as the fuel to keep it on going with those parameters. And then as you can see, as we go on throughout time, those parameters dwindle off, showing that the intensification is definitely not going to be able to, is going to be limited after 10 p.m. and is going to start to reduce. But with that, that could increase the chances for damaging winds and more of the downdrafts of the storms. Next, let's go ahead and take a look at our supercell composite. That's going to also show the 500 millibar and 850 millibar crossover of the winds. So here we are, 7 a.m. on Friday. So we go ahead in time, we can see as far as that instability building and parts of Arkansas and Missouri and even into Iowa. As we get to 0Z, right, the 7 p.m. Central Daylight Time, we can see a certain area right there in that southeast Missouri. So let's go ahead and give it a click and take a look at our first sound. And as you can see in this sounding, especially these kinematics look insane. So there is a lot of speed shear and even directional shear too. We're going to have over 1,600 joules per kilogram as far as our Cape. Our lifted index is -6, so sufficient to work with. We're going to have more of a backed wind or more of a kind of a south-southeasterly wind. And then it's going to be, they'll be turning over time. So the winds are going to be veering. There's no backing winds or cold air advection all the way up into the equilibrium level to where the parcel is no longer warmer than the temperature. So then that way, this is pretty much going to be like your echo tops. And as we can see, so we have our LCL that's right here. And the FAT 3 Cape is 168, which is going to be strong, anything over 100 joules per kilogram in the 0 to 3 kilometer area. Which kind of give you a little graphic. It's going to show that. So we definitely have a lot of explosion. This storm relative helicity is absolutely insane. 792 meters squared per second squared of effective storm relative helicity. In addition, the BRN shear is 287 meters squared per second squared. So the BRN shear is going to show you kind of like the wind shear for more of like the 0 to 3 kilometers. And that number is astronomically high. So definitely looks like chance if this actually develops in their storms as far as possibly long-lived devastating tornadoes could definitely be a factor in this setup and is definitely should not be taken lightly. And then going over just a little bit more here, we can see our PWatt values is 1.09 inches, which anything right around about 1 inch is going to be more on the low precipitation side. So it is even possible that this could be even more of like a photogenic type of cell. And then let's do one more little factor here. We can see 700 to 500 millibars of the lapse rate is 6.9 degrees Celsius per kilometer. Usually like that about 7, but you know, that's a pretty solid area too. And as you could see, that's going to be as far as the difference from here to here. So if this gradient becomes more, then those lapse rates going to increase. But even as you can see here with 8.4 degrees Celsius per kilometer, that's just a little bit higher up. It definitely shows as far as there could be definitely some large hail with this, especially in LPs. It's going to be less chance to for the precipitation to get in the way for the hailstone growth. And then we also have our decay value at 731, which is a moderate chance for damaging winds. So at this time in the southeast Missouri, it looks like violent tornadoes are definitely possible, and also large hail and even some damaging winds. Finally, we're going to go jump back to the NAM nest, or the NAM 3 kilometer, to look at the simulated reflectivity. This does not necessarily mean this would be accurate, but it definitely shows us a good indication of what might happen. So here we are, 7 a.m. As we go out through time, we can see as far as that line starting to develop in parts of the border of Kansas and Missouri. It's going to be evecting off, creating that line. And we even see some more of some development happen in that southeast Missouri region we're just talking about. And if there's definitely any supercells ahead of that line, it looks to be like there could be a high chance for tornadic probability. And even as that line transverse off to the eastern direction, damaging winds and also large hail is definitely going to be a good risk. So altogether, I hope you enjoyed this video. I believe that as far as the most intense timing is going to be between the hours of 4 p.m. and 10 p.m. Central Daylight Time, which I believe at current run in the model, about 7 p.m. Central Daylight Time, things are going to be peaking. So you want to make sure that you're being weather aware, have some kind of alert system, have some kind of monitoring going on, because this is definitely not anything to take lightly. And even on the following day and Saturday, which I'll probably cover in a video tomorrow, it doesn't look like it's going to get any better. It looks like severe weather probabilities could possibly even increase from this. So once again, thank you for watching. I hope you enjoyed this video, and until next time.